name is Kyle Barryuga, and I'm an MET student at Central Washington University, and my senior project is the Articulating Balsa Wood Bridge. Today I will be introducing my engineering problem for my project, why I chose to do this project, the types of engineering that are required to solve the engineering problem, the time and cost investments, and why I believe this project will be successful. So my engineering problem is to design and build a bridge that allows passage of an object across and under it. Some of the specific requirements is it needs to support a load of 20 kilograms. The weight of the bridge needs to be less than 85 grams. And the max vertical deflection when a 20 kilogram load is applied cannot exceed 25 millimeters. My motivation for the project comes from seeing all the different types of bridges and bridge designs and how they are able to support loads multiple times their weight. Like in my case, I have to build a bridge that is less than 85 grams, but it has to support more than 200,000 times its weight at 20 kilograms. And I know that's not too heavy, but just the ratio of weight to load that it has to support is very fascinating to me. On top of that, I'll be using balsa wood, and it isn't a very strong material to begin with, so manipulating it to support that amount of weight for this project is also very fascinating. The types of engineering involved in this project are mainly statics and mechanics of materials. Looking at a good example of this in one of my analyses. In this analysis, I find the area of the truss members. After creating a free body diagram, some of the forces and some of the moments can be used to find the reactions at the ends, where they will contact the abutments. In this analysis, particularly one thing to consider is, since it is only half of the bridge, the applied force is half. So then, by using method of joints, the compression and tension forces are calculated. Then through mechanics of materials, the stress equation can be used in addition to referencing the compressive and tensile strength of balsa wood, and then the minimum cross-sectional area can be found. Then by setting conditions for the size of the balsa wood being square beams and having them be the same cross-sectional area across the whole bridge, the best size for this analysis was 1/2 inch by 1/2 inch. Looking at the schedule, a lot of time was spent on writing up the proposal and doing analyses. Since most of the drawings were just square beams at varying lengths, they didn't take up too much time. They were all pretty simple. At first, it was a little challenging to get the proposals, the analyses, and drawings done weekly, but after planning and creating the Gantt chart, it definitely was much easier to complete those tasks. Looking at the budget, since most of the parts will be, like I said, just the same size with a square cross-sectional area, a lot of them can be used from just one bulk purchase. The other items will also be purchased from different storefronts, or it will be created here at CWU. When considering the total budget, like labor costs, the estimated total comes out to be a little over $6,100. Obviously, the labor costs won't be included in the total cost, but just to have it there. Regarding the project as a whole, I believe it will be successful because I put a lot of time into why I'm doing this project in the first place. I've invested a lot of time into making sure the engineering is correct. Also invested a lot of time into planning and executing tasks for this fall quarter. I've also put a lot of time into planning for construction of the bridge next quarter in winter, and also planning for testing in spring quarter. So With all of that, I do believe this project will be successful. Thank you.